In the last section that we did on, well, not the last section, but a previous section we did on factoring, we talked a little bit about what's called perfect square trinomials. When we factor perfect square trinomials to solve quadratic equations, or even just solving quadratic equations in general, sometimes a good useful tool is just to take the square root on both sides to help find our solution. Anytime that we take a square root, so let's say I'm taking this. I'm trying to solve this, and I solve it by taking the square root on both sides. It's really important that we remember to add plus or minus to our solution. Because here's my original problem. The reason why you have to include plus or minus is because, a number and its opposite, its negative counterpart, have the same square. Like, for example, 3 squared is 9. Also, negative 3 squared is also 9, because that's negative 3 times itself. Negative times a negative is a positive. Okay. Let's say I have an equation like this. Let's see. 4x squared plus 10 equals 36. No, I'm sorry, 46. 46. Okay. So I notice that I don't have a middle term, but also I don't have a difference of squares. I don't have a difference of squares here. Now, if I subtracted 46 on both sides, I could have a difference of squares. That's just one way to do it. But then you'd have to, do factoring and add some extra steps. Well, really, when you don't have a middle term, the easiest route to go would be just to solve for x, because there's only one term that has an x in it. So I'm going to take the path of least resistance here and just solve for x. 4x squared equals 36. I'm going to divide by 4 on both sides. X squared equals 9. Take the square root on both sides. X equals plus or minus 3. Okay. And if I wanted to check my original problem, negative 3 and positive 3 squared are both 9. So 9 times 4 is 36, plus 10 it being 46. So it does end up working out in the end. But one thing that we can check. There's another way that we can check to see if a quadratic function is a perfect square trinomial. There's a simpler way to do that factoring process. So if I let f of x be x squared plus bx plus c. So keep in mind I'm using this particular form with a being 1. Okay, and there is a reason for that. Now, if this is true, let's say that c is equal to b over 2 squared. Now, if that's the case, then this plus bx plus b over 2 squared. Then what happens here is, let's check to see if this is a perfect square trinomial. So I have a perfect square here and a perfect square here. Now, the question is, does 2 times 2 times a squared, 2 times n times, does 2 times my value for a times my value for c, does that equal to my middle term? So 2. So these 2's would cancel. 1 times b would be b, in which case it does check out. So this is actually a perfect square trinomial, which means that this can be factored to x plus b over 2 squared. Now, why is this important? If I want to solve a quadratic equation, but the quadratic function is not a perfect square, we can find a way to make it a perfect square, and we can still use some square roots to solve that equation. And all this is done All this is done through a process called completing the square. So I'm going to take a quadratic function that is not a perfect square trinomial, and I'm going to make it into a perfect square trinomial. So when we start the process, we have an equation. A quadratic equation equals some number. First step, if a is not equal to 1, then we can't use the proposition that we just mentioned before. So if a is not 1, then we have to divide everything by a, at whatever a is. Okay. Second step, you want to collect all of the variable terms on one side, constant terms on the other side. Now normally for completing the square, you want to, or not for completing the square, like when we're solving quadratic equations or solving any equations, you almost always want to try to get everything on one side. But for completing the square, that's not necessarily the case. Okay? If we're completing the square, then we want to make sure that all the variable terms are on one side, and then the constant terms are on the other side. Then here comes the actual completing the square part. Complete the square by adding b over 2 squared to both sides. And that's what it means to complete the square. We're adding something on both sides so that our variable side is now a perfect square. That's why it's called completing the square. Then, of course, as I mentioned just now, we want to factor. And when we factor, that trinomial that we just made is now a perfect square trinomial that becomes, so we're going to factor into x plus whatever my b over 2 was squared. All right, then we get to the solving part. First things first, take the square root on both sides. It's really important that we do not forget the plus and minus. We cannot forget that. Absolutely not. And then, of course, we want to solve for x. And then, of course, so that's how you complete the square. So if I wanted to use an example of just the completing the square part, I'll do that over here. Let's say I have x squared minus 10x, and I want to complete the square here. Well, first things first, I want to find what my b over 2 squared is. So here, again, a is 1, b is negative 10. So b is negative 10, so that means that b over 2 is negative 10 over 2, which is negative 5. Now, when you find your b over 2, find some kind of way to remind you to come back to that. Because when we factor that perfect square trinomial, that number is what's going to be in that factor. Okay? So b over 2 squared is negative 5 squared, which is 25. So if I write x squared minus 10x plus 25, so again, I have x squared being a perfect square, 25 being a perfect square, right? So I have 2 times a times c, so 2 times 1 times 5 being 10. So again, it works out. That is a perfect square trinomial. So now this will factor to x plus b over 2, so that's negative 5, so that's x minus 5 squared. And now it's completely factored as a perfect square trinomial. Okay. Let's try this process let's try this process with without completing the square and with completing the square. So here's an example. I have x squared plus 4x plus 4 equals 25. So I'm going to tell you right now, this is already a perfect square. All right? This is already a perfect square. But let's say that I had something like this. X squared plus 4x equals 21. Well, my a is not 1, so step 1's good. All my variable terms are on one side. So that's also, and the constant terms on the other side, so that's good. So what's my b over 2? So b is 4. So b over 2 is 4 over 2, which is 2. So I'm going to come back to that when I factor. So I'm going to add b over 2 squared. So b over 2 squared, that's 2 squared, which is 4. So I'm going to add 4 to both sides. X squared plus 4x plus 4 equals 21 plus 4. Because remember, what you add on one side of an equation, you have to add to the other side. Okay? So now, this is a perfect square trinomial. This is the number that's going to be inside that factor. That's positive, so that's x plus 2 squared equals 21 plus 4, which is 25. So again, that's done. Steps 3 and 4 are done. So now step 5 and 6, taking the square root and solving. So the exponent and the square root cancel out. X plus 2 equals plus or minus 5. Now here's why the plus and minus is important. Because now I have to take this expression and split it up. X plus 2 equals positive 5. X plus 2 equals negative 5. All right, subtract 2. X is 3. X is negative 7. So let's try it back in our original problem. So 3 squared is 9. 4 times 3 is 12. 9 plus 12 is 21. That's good. Negative 7 squared is 49. Negative 7 times 4 is 28. 49 minus 28 is also 21. So it all checks out. It all checks out. Okay. Now let's try one where my value of a is not where my value of a is not 1. Here is, there it is. So this is 3x squared minus 12x plus 6 equals 0. Go ahead and erase this here. 3x squared. Yeah. Here's my problem. 3x squared minus 12x plus 6 equals 0. All right, so first things first, my a is not 1. So I have to make sure, I have to divide everything on both sides by 3, even this, to make sure that my a is 1. Okay, so that cancels, x squared minus, x squared minus 4x plus 2 equals 0. 0 divided by 3 is 0. Okay. Next, so step 1's done. Step 2, all the variable terms are on one side, but I need this to go to the other side so I can complete the square. X squared minus 4x equals negative 2. So now, as it turns out, my b is similar to the previous problem, except instead of plus, I have minus. So my b over 2 is negative 4 over 2, which is negative 2. I'm going to take that and square it. Equals negative 2 squared, which is 4. So I'm going to add 4 to both sides. X squared minus 4x plus 4 equals negative 2 plus 4. Okay. So again, this is now a perfect square trinomial. That's my b over 2. So it will factor to x minus 2 squared equals negative 2 plus 4, which is positive 2. And so now, take the square root on both sides. X minus 2 equals plus or minus 2. So again, we have to split it up like before. x minus 2 equals positive 2, x minus 2 equals negative 2. So x is either going to be 4 or 0. X will be either 4 or 0. Oh, actually, no, hold on a second. I messed that up. Turns out, square root of 2 is not a perfect square. 2 is not a perfect square, so I actually have to leave that as it is. So I have x minus 2 equals square root of 2. X minus 2 equals negative square root of 2. Add 2 to both sides. And my solutions are 2 plus the square root of 2 and negative 2. I'm sorry, 2 minus the square root of 2. Those are my solutions. Okay. One last thing. So earlier on in this section, we were able to take a standard form, a vertex form, I should say, quadratic function, and turn it into a standard function by multiplying and expanding. And technically, you can also use standard form to go to vertex form by identifying its vertex and using the vertex and the value of a. But you can also use completing the square to do this as well. And the steps for that are very similar to these steps with a few minor changes. So completing this, so to complete the square, to convert from standard to vertex form. So the first few steps are kind of the same. So first you want to, if your a is not 1, you are going to technically divide both sides, but instead of dividing, what you're actually doing is you're going to have to factor a out of the variable side. Or just factor a out on both sides. Factor out a in every term, I should say. Then, obviously, step 2 doesn't really apply because we do want everything to be on the same side. So your actual step 2 is to add and subtract b over 2 squared in the equation. By doing this, we're adding b over 2 squared to complete the square so that we can factor this into a perfect square trinomial. All right? And we're subtracting b over 2 squared to keep it balanced, because I can't just add something to an expression. I have to add and subtract it to keep it balanced, like I would an equation. Step 3, you're still going to factor. Into the perfect square trinomial. Step 4, you want to, so because you're subtracting b over 2 squared as well as adding it, what you do want is to combine whatever your c is with your b over 2 squared, combining those two terms. And then, because if my a is no longer 1, we kind of want to redistribute a if necessary. Okay. Now we'll do an example so that you can see this done in action. Okay. So I want to convert this quadratic function into vertex form, and it is x squared plus 4x minus 6. Okay. Now I don't have it. My A is not. My A is positive 1, so I don't need to do this first step. Okay. So I can go to the next step. So I need to figure out what my B over 2 squared is. So my B over 2 is 4 over 2, which is 2. Okay, I'm going to start that so I can come back to it, which means that B over 2 squared is 2 squared, which is 4. So I'm going to add and subtract 4 at the same time to keep it balanced. So I have x squared plus 4x plus 4 minus 6. And again, the reason I can do that is 4 minus 4 is 0. If 4 minus 4 is 0, 0 minus 6 is negative 6. I haven't changed the problem. I just rewrote it a different way. And I'm rewriting it this way so that I can factor this out and combine these. Okay? So, this will factor to x plus 2 squared. Negative 4 minus 6 is negative 10. Okay. If I wanted to check, my vertex is negative 2, negative 10. Let's see if negative 2 plugged in here gives me negative 10. So negative 2 squared is positive 4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4. Negative 4 minus 6 is negative 10. So it actually does end up working out. Let's do an example where my A is not 1. And that'll be the last thing. We'll do an example where my A is not 1. Let's see. Okay, here we go. Let's see. 2x squared minus 8x plus 1. All right. So again, here's my A. I want to get rid of it. So I'm going to factor a 2 out of all these terms. X squared minus 4x plus 1/2. So now my new B is negative 4. All right, so negative 4 over 2 is positive 2. Negative 2 squared is positive 4. So I'm going to, again, add and subtract 4 at the same time. Okay, so 2 times x squared minus 4x plus 4 minus 4 plus 1/2. So now I'll factor this out and I'll combine these two. So this becomes x minus 2 squared, and then I just need to calculate negative 4 plus 1/2, which I believe is, let's see, so negative 8 over 2 plus 1 over 2, that's negative 7 over 2. So minus 7 over 2. Now I'm almost done. I just want to go ahead and redistribute this. When I redistribute this, I'm only going to put it here. I'm not going to multiply this into all this. I'm just going to move the 2 here, but I'm going to multiply also 2 times this. Okay? So that's 2 times x minus 2 squared. Again, I'm not going to multiply this out, but I am going to multiply this out. Minus 7, because the 2's will cancel. Okay? All right, so my vertex is 2, negative 7. Let's see if I get negative 7 when I plug 2 in here. 2 squared is 4. 4 times 2 is 8. Negative 8 times 2 is negative 16. 8 minus 16 is negative 8. Negative 8 plus 1 is negative 7. Does end up working out.